Hello again Year 9, this is Miss Pitt. Okay, we are now on our third video here, which will be looking at the conservation of mass. Okay, so the learning objectives for this video is you need to know the law of conservation of mass, what that means, and then you need to be able to explain what happens to mass in different chemical reactions. So we've got some examples to go through. Okay, so the law of conservation of mass. Well, the word conservation you might have heard when it comes to the environment. Okay, and it generally means to keep the same. So if you're trying to conserve the environment or conservation of the environment, you're trying to keep the environment the same. Okay, so that might prevent forests from being cut down or something like that. Now, conservation of mass simply means the mass is kept the same, okay? So in any chemical reaction, the mass of what goes into the reaction is the same as what comes out of the reaction. Okay, so you can imagine baking a cake. If all your raw ingredients are about 1 kilogram and you bake your cake, you would expect something near 1 kilogram to come out of the oven when your cake is baked. You wouldn't expect a cake that suddenly was 5 kilograms. Okay, so it's the same idea with chemical reactions. So we can look at some specific examples. Okay, and this will help us with the second objective be able to explain what happens to the mass in different chemical reactions. So we're going to look at the 4 chemical reactions that we've looked at so far. Okay, so our first one, okay, is our neutralization reaction. Okay, if you watch the 4th video that will be coming up soon, you will see a summary of all the reactions. Okay, so here we've got hydrochloric acid and sodium hydroxide. Okay, and I'm hoping that you're probably thinking what the products are. Okay, so these are the reactants, the things that go into the equation. Okay, and you should know, okay, that it's a neutralization reaction, so therefore we know that the product here will be water. Okay, and then we know here that there will be a salt. So naming the salt, okay, we can see that there's sodium there, so that will be the first word of our salt. And we can see that we've got hydrochloric acid. Okay, so the chloric, we should know, makes chloride salts. Okay, so we've got sodium chloride and water. Now if we just look at the mass of this, okay, by looking at mass we are looking at level 6 or 7, okay. If we had 15 grams of hydrochloric acid, okay, and we had 15 grams of sodium hydroxide, we know in total all the reactants going into the equation comes to 30 grams. That means on this side of the equation, when the reactions actually happened, we would also expect there to be 30 grams. Okay, so the idea, conservation of mass, is the mass that goes in is the same as what comes out. So if we've got 30 grams here, if for example we had 25 grams of water, you would expect there to be 5 grams of salt, because the 5 and the 25 make our 30 grams. Okay, so that reaction is fairly straightforward. If we look at another reaction here, okay, so here we've got a metal carbonate and an acid, okay, we need to know what the products are. Okay, now this one has 3 products, okay, and I'm hoping you're already shouting out the answers. The one here is going to be carbon dioxide. Okay, if you're struggling, okay, watch the 4th video, but the carbonate tells you it's carbon dioxide. Remember, 8 means there's oxygen hiding in there. Okay, we also know that one of the products here is going to be water, and we need to name the salt. Okay, so the first word is going to be magnesium, and the second word of the salt comes from the sulfuric acid, and we should know that sulfuric acid makes salts that are called sulfate. Okay, so we've got magnesium sulfate. Now, this reaction is quite interesting because a gas is produced. Okay, so if I show you a picture on my computer screen that shows you this, okay, just go from the learning objectives. Okay, so here we can see we've got a metal carbonate and an acid, and in total that comes to 3.861 grams. Okay, that produces a salt, water and carbon dioxide gas, also 3.861 grams. Okay, you'll notice on there though there's a balloon, and that balloon traps the carbon dioxide so that it can't escape. Now what's really interesting is if that balloon wasn't there, you would expect your balance after the reaction to have a mass that was less than 3.861, because the carbon dioxide that goes into the air takes the mass with it, or takes some of the mass with it. Okay, so it's really important to remember for this that gas has mass. Okay, so that's the phrase that you need to remember. Gas has mass. So any reaction where a gas is given off, it would look like the mass has reduced, but it hasn't really. It's just that the carbon dioxide in this case has gone into the atmosphere, taking some of the mass with it. Okay, if we look at some more equations, okay, so that's that one. Okay, so the next one here is we've got a metal and acid reaction. Okay, so from this you should know there are two products. One of them is hydrogen, and again the salt. Okay, so let's have a go at naming that salt. Can you tell what it is? So the first word is our metal, which is calcium, and the second word comes from our acid, so nitric acid. What type of salt does that make? It's a nitrate. So here we've got calcium nitrate. Okay, now let's have a look at what might happen here. Okay, if I've got 10 grams of nitric acid, okay, and 10 grams of calcium, we know that at the beginning there is 20 grams in total. Okay, if I did this reaction on a balance, I might find here that I've got 19.8 grams. Okay, showing on the balance. Why has it appeared to go down? It's because this hydrogen is given off as a gas and it takes some of the mass with it. Okay, if I could put the balloon over the top of the beaker like we just saw, then it would remain at 20 grams. But if I haven't got that balloon on, the hydrogen will go into the air and take the mass with it. Remember, gas has mass. So therefore the mass appears to have dropped, but it hasn't really. It's just that the hydrogens run off with it. Okay, now one more example for you, which is quite interesting. Okay, and this is our fourth word equation. Okay, so this is another example of one of the equations you need to know. Here we've got magnesium and oxygen, and I'm hoping that you know there's only one product for this, and of course it is magnesium oxide. Okay, now if I was to do this reaction on a balance or on some scales, something interesting would happen. If I started off with 10 grams of magnesium, okay, when I measure the amount of magnesium oxide produced, I might find that there's something like 12 grams. Okay, so why has the mass increased? Well, oxygen has come from the air and combined with the magnesium. So there might have been, or there will have been, 2 grams of oxygen that's come from the air and added to the magnesium. And that explains why the mass appears to have increased. Don't forget that oxygen would be in the air. Okay, so it would come from the air and add to it. Okay, so let's just go back to our learning objectives. Okay, know the law of the conservation of mass, the idea that mass has to stay the same, and be able to explain what happens to the mass in different chemical reactions. So remember, if there is no gas, if there's no gas being given off in the reaction, you know the mass before will be exactly the same as the mass after, when you combine the products and when you combine the reactants. If there is a gas given off, it will appear like the mass has dropped, and that's because the gas has taken some mass with it and gone into the air. And if you're adding something like oxygen, it looks like the mass increases, but remember, the oxygen mass comes from the air. Okay, so again, for all of these reactions, the mass is the same before and after. Okay, I hope you've enjoyed this video, and I will hopefully see you for the fourth and final video. Thank you for watching.